Hi everyone. This lecture is on chapter 18. In this lecture we will cover nutrition, and my cat Katara is here to help. An overview of nutrition and metabolism. Nutrition is the study of nutrients and how the body uses them. Recall from the last chapter that we talked about digestion and absorption, and I mentioned that food does not actually enter your body until it is absorbed into the bloodstream. And we learned all about the processes by which that occurs. And so what are nutrients? Nutrients are chemicals from the environment that organisms need for survival. They are used to supply energy to fuel metabolic processes. They are used for building blocks for producing the molecules the body needs. There are two major classes of nutrients: macronutrients and micronutrients. Macronutrients are required in large quantities, such as carbohydrates, lipids, proteins. They provide energy. Micronutrients are required in small amounts, such as vitamins and minerals. They help extract energy from the macronutrients. There are also essential nutrients, which are nutrients that the body cannot synthesize or cannot synthesize in sufficient quantity, and thus they must be obtained from the diet. Calories are the units of heat used to express the amount of energy in foods. You're mainly going to get your calories from your carbohydrates, lipids, and proteins, which are the macronutrients, and they provide energy. Let's start with carbohydrates. Carbohydrates are organic compounds such as sugars and starches. The energy held in their chemical bonds is used to power cellular processes. Your brain can only use sugar in the form of glucose to power its cells. That's why you get a sugar rush. There are several carbohydrate sources. There are polysaccharides, disaccharides, and monosaccharides. Polysaccharides are complex carbohydrates such as starch from plant foods and glycogen from meat. Disaccharides are double sugars, di for one, and saccharin is sugar. The disaccharides include milk sugar, cane sugar, beet sugar, and molasses. The monosaccharides, mono for one, and again saccharin is sugar. Monosaccharides are single sugars, and they are from honey and fruits. That's why those taste so sweet. Digestion breaks complex carbohydrates into monosaccharides that are small enough to be absorbed. In fact, the liver will convert the monosaccharides that are not glucose into glucose because that is the sugar that we can use in our bodies for our cell energy. Cellulose is a complex carbohydrate abundant in our food. It is not digested, but it provides fiber. Different monosaccharides are absorbed from the digestive tract. These include fructose, galactose, and glucose. Fructose is the sweetest of the monosaccharides. Since glucose is the most common cellular fuel oxidized in glycolysis, the other monosaccharides are converted into glucose by enzymes in the liver. Glucose is broken down into carbon dioxide, water, and energy when needed. Excess glucose is converted into glycogen by glycogenesis and stored in the liver and muscle cells. After storing a certain amount of glycogen, excess glucose is converted into fats by lipogenesis and is stored in adipose tissue. This is why high fructose corn syrup is so dangerous, as is a high sugar diet, because excess sugar is ultimately converted into fat. Many cells can break down fatty acids for energy, but some require glucose, like the nervous system I mentioned in the previous slide. Gluconeogenesis is the conversion of non-carbohydrates such as amino acids and glycerol to glucose for cells that require glucose as the energy source. Since this occurs when the body is starved of glucose, this is what people who are undergoing ketosis will go through in their bodies as they undergo gluconeogenesis to convert their amino acids and their glycerol from their fats in their diet to make glucose for their nervous system. This diagram, figure 18.1, shows the conversion of other monosaccharides into glucose. So fructose, glucose, and galactose are what we call isomers. They have the same chemical formula, C6H12O6, but they have a different chemical structure. And that's why the liver can convert fructose and galactose into glucose. So remember, if you overwhelm your liver with high fructose corn syrup, then it's going to have a hard time of converting all of that fructose into glucose, and it will store the excess as fat. And the companies are catching on to that, especially those who are marketing for nutritionally conscious consumers, and they are starting to take high fructose corn syrup out of their recipes. Figure 18.2 shows carbohydrate digestion and use. So the starch is a simple form of glucose. We find that in potatoes and rice and wheat. Sucrose is fruit sugar, also table sugar, and it has a glucose molecule and a fructose molecule, which is why it's so sweet. Maltose is going to be 2 glucose molecules. We find this in bread, and it is not very sweet. It's also in malted foods like malted barley and malted wheat. Lactose is composed of a glucose and a galactose monomer, and it is known as milk sugar. And not everybody can digest this sugar. Monosaccharides then are going to ultimately be converted into glucose, and then they'll be stored as glycogen or converted into fat if they are neither stored nor used for energy in the cellular respiration seen on the left-hand side of the figure. Carbohydrates are the primary source of fuel for cellular processes. The need for carbohydrates varies with individual energy requirements. The minimum requirements for carbohydrates in the human diet is unknown, but an intake of at least 125 to 175 grams a day is likely necessary. The average diet in the United States includes 200 to 300 grams a day. That's over twice the amount that is at least recommended. Now let's talk about lipids. Lipids are organic compounds like the carbohydrates. However, these are the fats, oils, phospholipids, and cholesterol. They supply energy for cellular processes, and they serve as building blocks for structures such as cell membranes. We're going to talk about the different types of lipids, starting with triglycerides. Triglycerides are composed of a glycerol molecule and 3 fatty acids. They are most commonly called the dietary lipids and are referred to as the fats. And so these can be saturated or unsaturated when you hear that term in your diet. And so saturated fats are mainly in foods of animal origin, such as meat, eggs, milk, and lard. They're also found in palm and coconut oils. What makes them saturated is there are no double bonds between the carbon atoms in the fatty acids. This causes them to have a straight line. I'm trying to see if we can see those. No, my apologies, sorry. They make a straight line like a brick is how I think about it. And so they are associated with increased risk of cardiovascular disease because since they're brick-like in their structure, they can form solids at room temperature. And so think about your body temperature. You know, it's over 90 degrees. And so still the lipids can form plaque in your heart, and it's going to instigate what's called a positive feedback loop, which can lead to heart disease. Next is the unsaturated fats. These are the fats found in seeds, nuts, and plant oils. They contain one or more double bonds between carbon atoms. So this gives them a kinky structure. Sometimes they're bent only in one place. Sometimes they have more than one double bond, and so they can be bent in many places and can even form almost like a circle. And monounsaturated fats, which are only bent at one place, are going to be the healthiest fats. Polyunsaturated fats are good in moderation. Omega-3 fatty acids are polyunsaturated fat that is more healthy than the omega-6 fatty acids. But unfortunately, in the American diet, we get more polyunsaturated fats that are omega-6 than we get omega-3. Cholesterol is another type of fat, and this is abundant in liver and egg yolk. This is not a triglyceride. Triglycerides are going to be a glycerol and a fatty acid. Cholesterol is a sterol. It's more like a wax. It's going to have these hexagonal shaped carbon rings that are going to be solid at room temperature, and they are also going to have a little hydrophilic tail. And so this makes them very important as stabilizers for the cell membrane. If you remember, the cell membrane is going to be like a fluid mosaic. So let's get to the phospholipids and talk about why. All right, so lipids in foods include phospholipids, cholesterol, and most commonly the fats/triglycerides. The function of lipids is they mainly supply energy. They contain more than twice as much chemical energy per gram as carbohydrates or proteins. Triglycerides are broken down to glycerol and fatty acids in order to release energy. And then the glycerol and fatty acids can be used to synthesize storage fats in adipose tissue. Excess glucose or amino acids can also be converted into fat molecules for storage. Your adipose tissue is kind of like a storage facility. A lot of those are popping up around the country as people are needing to store their things that they don't necessarily need, and they don't know what to do with them, and they don't necessarily want to get rid of them, or they can't get rid of them. And so that's what your body does to the excess glucose or amino acids and even some toxins that build up in your body. Here in figure 18.3 are the fat pathways in the body. So we start up here at the top with fat from foods, and then hydrolysis is the process of water coming in and cutting the molecules apart using that water. Hydro is water, lysis is to cut. On the left, we see that we have a glycerol, and your body can convert the glycerol to glucose through gluconeogenesis, which we just talked about. And then with acetyl coenzyme A, the fatty acids can then go into the citric acid cycle to form ATP, or they can form ketone bodies if your body is starving for sugars and you go into ketosis. And then you have the fatty acids, which are going to be your fat, and they will undergo beta oxidation, which again will go into the citric acid cycle with the help of acetyl coenzyme A and be used as energy. Or if your body is starving, it can go into the ketone body stage as you are in ketosis. The liver can convert fatty acids from one form to another. The liver cannot synthesize certain fatty acids called essential fatty acids. These must be obtained from the diet. Lipids can combine with proteins to form lipoproteins. They are classified on the basis of their density. As the proportion of lipids decreases, density increases. Lipoproteins are used in lipid transport to specific target cells. VLDLs are very low density lipoproteins. LDLs are low density lipoproteins, and HDLs are high density lipoproteins. The very low density lipoproteins, or VLDLs, are of a high triglyceride content. The low density lipoproteins, or the LDLs, have a high cholesterol content. And the high density lipoproteins, or the HDLs, have a high protein content. The liver controls the cholesterol level. Produced by the liver, the cholesterol will be released into the blood, and it can be used to make bile salts. It can be excreted in bile, and then adipose tissue stores and releases triglycerides as needed. So this also goes back to the last chapter where we talked about how the gallbladder will store the bile and bile salts. And so with high cholesterol, the cholesterol can crystallize and it can become gallstones that can back up and block the bile ducts in the gallbladder. Figure 18.4 shows the fatty acid usage by the liver. We see that triglycerides are broken down into fatty acids and glycerol, and from that we can get triglycerides, lipoproteins, fatty acids, cholesterol, and phospholipids. The lipid requirements are going to vary in the human diet. However, the American Heart Association advises that the diet does not exceed 30% of the total daily calories from fat. Recall that monounsaturated fats are the healthiest, and you find those in avocados and olives. And they are healthier than saturated fats, which are found in butter and lard. People have different lipid requirements based on the stage of life and their activity level. Fat intake must be sufficient to support the absorption of fat-soluble vitamins. And also, don't run away from butter and go straight to margarine, because margarine is what's called a trans fat, which you've heard of now. The trans fat is when they convert a unsaturated fatty acid to a saturated fatty acid to make it more solid at room temperature. So your best choices are, avocado oil, olive oil, and then if you are going to use saturated fats, use the real butter, because it does have some like DHEA in it. That's really important fatty acids. I don't know if you should ever use lard for anything. I know down here in the South we fry chicken with it, and that's why I can't eat fried chicken. Now let's talk about proteins. Proteins consist of chains of amino acids, which is going to be made up of an amino group, as seen below, and a deaminated portion, which will be an acid. Proteins have many functions, including building new proteins. These are structural proteins, enzymes, hormones, antibodies, clotting factors, and other plasma proteins. And proteins also supply energy. So back to that deaminated portion, that's when they take the amino group off of the acid. And so the acid is actually going to be COOH. I like to think of acids as COO. And so amino groups, which are the nitrogenous base, NH2, are removed through deamination, and they react to form urea, which is excreted in urine. Some animals will excrete the waste products as ammonia, but our bodies break that ammonia down into urea because it is less toxic. Excess amino acids can also be converted into glucose or fats. Figure 18.5 shows protein usage in the body. We see that protein through digestion is broken down into amino acids, and there's a wealth of things that proteins can do. And so I want to focus your attention on the left side of the figure. You can see that there's structural proteins, enzymes, hormones, and plasma proteins. With that said, from what I understand, you want to use proteins to build. You want to focus more on your glucose and your fats from your diet for your energy. You don't want to have to convert your amino acids into glucose or fat for energy. This is another example of the protein pathways in the body. Here we see the amino acids come in, and we have deamination, meaning we take the amino part away. There's your nitrogenous base groups, and that will be converted into urea, which is a less toxic form of nitrogenous waste than ammonia. Aquatic animals can secrete ammonia directly into the water, and normally it will be filtered away from their body, which is why you have fish filters in your tank, and you have to check the ammonia levels regularly. It's from the fish pee. And so here we see that there are also deaminated portions that can be converted into fat or glucose, or with acetyl coenzyme A again, go into the citric acid cycle to make energy. But we want to focus on structural proteins, enzymes, hormones, and plasma proteins being the goal of our amino acid digestion. Foods that contain proteins include meats, fish, poultry, cheese, nuts, milk, and eggs. Of those, lean meats and fish and poultry are going to be great sources. Cheese in moderation, because it does come with a lot of saturated fats. Nuts have a lot of monounsaturated fats, but they can still cause weight gain if consumed in large numbers. But nuts also have vitamin E, and so they're very healthy. Milk, if you're going to drink milk and you can handle whole milk, drink whole milk, because those fats in the whole milk are going to be very beneficial to you, kind of like the fats in that butter I was mentioning. And then eggs. Eggs get a bad rap because of cholesterol, but they are now earning their proper place in the food chain as a very essential source of protein and other nutrients. Legumes contain protein. However, they contain less protein because they are going to be what we call plant proteins, which are not as bioavailable. But if you combine legumes with a high quality carb like beans and rice or hummus and pita bread, then that makes a complete protein. The body needs 20 types of amino acids to synthesize proteins. 12 can be synthesized by the body, and these are called non-essential amino acids. 8 cannot be synthesized and are thus called essential amino acids. All 20 amino acids must be present at the same time in order for protein synthesis to occur. If even one amino acid is missing, any proteins that require that amino acid cannot be produced. Essential amino acids are not stored in the body. And sickle cell anemia comes from the deletion of one amino acid in the hemoglobin chain, and it changes the structure of the hemoglobin and thus changes the structure of the red blood cell. And it's just one amino acid. So complete proteins are high quality proteins that contain adequate amounts of the essential amino acids for good health. They're found in meat, milk, and eggs. Incomplete proteins or low quality proteins do not contain adequate amounts of essential amino acids, and they're found in many plant proteins. And so that's why, as I said earlier, certain combinations of plant proteins, such as beans and rice, provide adequate diversity of the dietary amino acids. I think another one is like corn and beans. Table 18.1 shows the different types of amino acids in foods. And there are 8 essential amino acids that cannot be synthesized by the body. And so that's what the E is for. And then 2 additional amino acids are essential in growing children, meaning they can't make that when they're children. In healthy adults, protein is continuously built up and broken down. Overall gain should equal overall loss, resulting in a state of dynamic equilibrium. Since proteins contain a high percentage of nitrogen, dynamic equilibrium leads to a state of nitrogen balance, in which the amount of nitrogen taken in equals the amount excreted. A negative nitrogen balance develops from starvation. The excretion exceeds dietary intake. Positive nitrogen balance develops in growing children, pregnant women, or an athlete in training. The protein being built into new tissue exceeds the energy usage and excretion. Besides supplying essential amino acids, proteins provide nitrogen and other elements for producing non-essential amino acids and certain non-protein nitrogenous substances. Dietary protein intake varies according to body size, metabolic rate, and nitrogen balance condition. Sorry for that noise, it's my chair. Typically, daily protein intake is recommended to be 10% of a person's diet, which equals 0.8 grams per kilogram of body weight, or in American, 0.4 grams per pound of body weight. Most people should consume 60 to 115 grams a day, or in American, 2 to 5 ounces a day. Deficiency of protein leads to tissue wasting and a decline in plasma proteins, which results in decreased plasma osmotic pressure and can cause nutritional edema, which you see in protein deficiency diseases in starving children, particularly. Their tummies swell. Table 18.2 shows the carbohydrate, lipid, and protein nutrients. It's a nice wrap up for this section. Now let's look at energy expenditures. Carbohydrates, fats, and proteins supply energy for all metabolic processes. Deficiencies can cause consumption of structural molecules such as muscle proteins, which can lead to death. We call these wasting diseases. Excesses can lead to obesity, which is also damaging to health. As you know, it can lead to diabetes and heart disease and cancer. The energy values of foods are measured in calories, which is the potential energy a food contains. Calories are actually units of heat. The caloric content of foods can be measured by a BIOL calorimeter. Caloric content of various types of nutrients are as follows. Protein has 4.1 calories per gram, which we generally just say 4. Proteins have 4.1 calories per gram, again, generally just 4. And then lipids, we usually say 9 calories per gram, but here the source says 9.5 calories per gram. So basically, lipids have twice the energy amount as either carbohydrates or proteins, which is another reason to limit them in your diet. Don't totally cut them out. We tried to do that in the 80s and 90s, and that's why we all became like horrible sugar addicts, and we learned the hard way that sugar in excess does not replace fat. They used to replace everything in foods that used to have fat. They'd be low fat but high sugar, and it was a disaster. This is a BIOL calorimeter, and so it goes in and it measures the amount of heat that is released per unit of sample in a food. The basal metabolic rate, or BMR, is the rate at which the body expends energy under basal conditions, meaning you are awake and at rest and overnight fasting in a comfortable environment. And so this is kind of like your baseline homeostasis. And this is one of the reasons why you go in and take like fasting blood tests when you go to the doctor, because this mainly reflects the energy needed to support the activities of the organs. The basal metabolic rate varies with gender, body size, body temperature, and thyroid hormone activity. Maintaining the basal metabolic rate requires the body's greatest energy expenditure. And so this is just how many calories basically you use per day just to stay alive. And energy is needed in the body to maintain basal metabolic rate, to support muscular activity, to maintain your body temperature, and for growth in children and pregnant women. Whenever you exceed your basal metabolic rate in calories, like you take in more calories than what your basal metabolic rate requires, you can tend to gain weight. If you are deficient in your calories and you have higher caloric needs in your body than what you take in, you tend to lose weight. And so table 18.3 shows you some calories burned per hour doing various exercises. I went swimming today, 500 calories, and I swam an hour, so yay. All right, energy balance exists when caloric intake from food equals caloric output from the basal metabolic rate and muscular activities, and thus the body weight will remain constant. A positive energy balance means caloric intake exceeds output. Tissues store excess nutrients, and it leads to weight gain. A negative energy balance is when caloric expenditure exceeds intake. Tissues are broken down for energy, and this leads to weight loss. The tissue you want to break down for energy, of course, is adipose tissue, not proteins. The most common nutritional disorders involve caloric imbalances. A desirable weight is difficult to determine. The body mass index, or BMI, is used today to assess weight, taking height into consideration. A person is classified with BMI as either underweight, normal weight, overweight, or obese. And of course, this can have problems because If a person has a high amount of muscle mass, then they might go into the overweight category versus someone who does not. And just because you are overweight does not necessarily mean that you are not healthy. Overweight is defined as exceeding desirable weight by 10 to 20% or a BMI of 25 and 30. So overweight, you want to watch it, but when you get into obesity, this is when we start to see the diet-related diseases such as cardiovascular disease, diabetes, and all of that set in. So obesity is defined as exceeding a desirable weight by greater than 20% or with a BMI over 30. Also, where you carry your weight is very important. Abdominal or visceral body fat is more detrimental than carrying body fat in the lower extremities, like the hips and thighs. Figure 18.8 shows a body mass index or BMI chart. And so what you do to find your BMI is you go to your height and then you go over to your weight in pounds. So I'm going to spill the beans on myself here, and I'm right around here. I'm finally in the 145 range with lots and lots of work, and I'm trying to maintain it, but I'll teeter up to 150. And so that's a milestone that I tried to get back into and work very diligently. It gets harder as you get older, for sure. So much so that almost a third of the adults in the United States are obese, with 20% above desirable weight and having extra pounds of fat in the body. So unfortunately, obesity increases the risk for type 2 diabetes, digestive disorders, heart disease, kidney failure, hypertension, stroke, and certain cancers. And so definitely no body shaming ever, but we want body positivity, but we also need body healthy. And keep in mind that both hereditary and environmental factors can contribute to obesity. Certain genes are involved with the control of hunger and satiety by the hypothalamus. And another thing that can happen is apparently the more adipose tissue you have, like it can actually release hormones as well that can make you hungry, particularly if you are in the process of losing weight. The adipose cells can send hormones into the body to make you hungry because you need to fill those fat cells back up. Once you have fat cells, they only swell or shrink. You don't actually lose fat cells when you lose weight. You only drain them, but the fat cells are still there. But they can multiply. So as you gain weight and those fat cells fill up, they can multiply to make new fat cells, which again, you keep forever. So it's an endless cycle. And again, I've lived it my whole life. So treatments are diet and exercise. Losing a pound requires burning 3,500 calories. I mean, that's a lot. That's crazy. It's hard work. Drug therapy can be effective, but many drugs are harmful. Ozempic's in the news now, right? And then surgery. There's 3 types of bariatric surgery that are used to treat obesity. Appetite control. The appetite is the drive that compels us to seek food. The control center is located in the hypothalamus, and it's under the control of several hormones and neurotransmitters, including insulin, leptin, neuropeptide Y, and ghrelin. Insulin is the hormone secreted by the pancreas after eating. It stimulates adipocytes to take up glucose and store fat, and other cells to take up glucose and store glycogen. Leptin is a hormone secreted by adipocytes while eating. It acts on the hypothalamus to suppress your appetite by inhibiting the release of neuropeptide Y. Neuropeptide Y is a neurotransmitter secreted by the hypothalamus in response to the hormone ghrelin, and it stimulates the appetite. Ghrelin is the hormone secreted by the stomach and enhances appetite by causing the secretion of neuropeptide Y. I kind of live in the neuropeptide Y and ghrelin realm of hormones always. So I try to eat more protein and fat. I'm not keto by any means, and I eat too much sugar, I'm sure. But I do find that when I eat protein with a bit of fat, it slows down my digestion, as we talked about in the last chapter, and it keeps me satiated longer. Table 18.4 is reviewing the substances that control appetite. And of course, you also get cravings because studies have shown that cravings elicit responses in the brain in regions that are similar to the regions that respond to drugs, such as cocaine. It's all about that dopamine and serotonin release. So this shows the leptin and ghrelin cycle. And now we're going to get into the nutrients that are not energy providing nutrients, but they aid in the absorption and usage of the energy nutrients. Vitamins are organic compounds that are required in small amounts for normal metabolic processes. They are essential nutrients and cannot be synthesized by body cells in adequate amounts. Vitamins are classified on the basis of their solubility. There are fat-soluble vitamins and water-soluble vitamins. The fat-soluble vitamins are vitamins A, D, E, and K. I remember it as ADIC. And water-soluble vitamins are B vitamins and vitamin C. So B and C. Table 18.5 shows vitamin fallacies versus facts. So the fallacies, the more vitamins, the better. Fact, too much of a water-soluble vitamin results in excretion of the vitamin through urination, and too much of a fat-soluble vitamin can harm health. Fallacy, a varied diet provides all needed vitamins. Fact, many people do benefit from vitamin supplements, particularly pregnant and breastfeeding women. Fallacy, vitamins provide energy. Fact, vitamins do not directly supply energy. They aid in the release of energy from carbohydrates, fats, and proteins. The fat-soluble vitamins dissolve in fats, and they are influenced by the same factors that affect lipid absorption. Bile salts will promote fat-soluble vitamin absorption. Fat-soluble vitamins are stored in various tissues, so excess intake leads to overdose, which can be harmful to health. Fat-soluble vitamins are resistant to heat and are not often destroyed by cooking and or food processing. And these fats include vitamins A, D, E, and K. And that's good about vitamin E because, as I mentioned earlier, nuts are a good source of vitamin E, and so nut oils like sunflower oil is resistant to being destroyed. Table 18.7 summarizes the fat-soluble vitamins, and I'll let you look at that for your review. Water-soluble vitamins include the B vitamins and vitamin C. Cooking and food processing destroy some of them, so it's important not to overheat your vegetables or nuke them in the microwave. B vitamins are essential for normal cellular metabolism. B vitamins are usually found in the same foods, and so together they are known as the B vitamin complex. And it's pretty cool. It ends up looking like a little raft, if you would, and they go in and they help the coenzymes in the electron transport chain shuffle electrons to the final electron acceptor, which is oxygen. And so that's why you see B vitamins sold as energy enhancers. Table 18.8 summarizes water-soluble vitamins. So just because it's like vitamin B and C, don't think it's easy. It's actually more complicated. There are a lot of B vitamins. Look at all that. And then, of course, vitamin C is one of those. Minerals are inorganic elements required in metabolism, and they are usually extracted from the soil by plants. Minerals are obtained from plant foods or animals that have eaten plants. Minerals make up about 4% of the body weight, and that's because they're most concentrated in the bones and in your teeth, such as calcium, phosphorus, and in the hydroxyapatite crystals of the skeleton and the fluoroxyapatite crystals of the calcium fluoride in your teeth. Minerals are usually incorporated into organic molecules, such as iron in hemoglobin. Iron is in the center of the hemoglobin structure. Some minerals exist as parts of inorganic compounds, like calcium phosphate. Some are free ions in the blood, like sodium, chloride, potassium would be an example. Minerals compose parts of the structural materials of all cells. They have roles in muscle contraction, nerve impulse conduction, blood coagulation, pH regulation, etc. One central mineral that is involved in the muscle contraction, nerve impulse conduction, and blood coagulation is calcium. Homeostatic mechanisms regulate the concentration of minerals in body fluids, and mineral toxicity can result from ingestion of too much of a mineral or from overexposure to industrial pollutants, household chemicals, or certain drugs. There are major minerals in the body called macrominerals that account for 0.05% or more of the body weight, and they include calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. Calcium and phosphorus account for nearly 75% of the mineral elements of the body by weight because they are found in the skeleton as hydroxyapatite crystals. Table 18.9 lists the major minerals for your review. Trace elements are called microminerals, and they are essential minerals found in minute amounts. Each makes up less than 0.005% of the body weight. Though they may be microminerals, they are mighty though, because look, they include iron, magnesium, copper, iodine, cobalt, zinc, fluorine, selenium, and chromium. Already you recognize iron, that's essential for the hemoglobin molecule and to transport oxygen in your blood, and iodine is essential for proper thyroid functioning. And we know that copper and zinc are important for heart as well as other metabolic processes. Zinc is also an immune system booster, as we know. So table 18.10 summarizes the trace elements. Clinical application for 18.2, dietary supplements. Proceed with caution. Dietary supplements are not classified as either a food or a drug. They may contain ingredients that function like pharmaceuticals in the body, and they may be toxic if taken in excess. Supplements are regulated by law and must contain a vitamin, mineral, herb, botanical, etc., and must be intended to supplement the diet. Product labels cannot state that a supplement diagnoses, prevents, treats, or cures any disease. They can only state facts that are supported by evidence, such as the fact that calcium decreases the risk of osteoporosis. Some supplements may have little value, such as those that supply chemicals that are produced in sufficient quantity in the body. Some can be dangerous because of their interaction with certain other drugs that the person may be taking. The FDA does not require clinical trials to prove that supplements are safe and effective. An adequate diet provides sufficient energy, calories, essential fatty acids, essential amino acids, vitamins, and minerals to support optimal growth and to maintain and repair body tissues. Requirements vary with age, sex, growth rate, level of physical activity and stress, and genetic and environmental factors. If food supply is adequate, most healthy people obtain proper nourishment by eating a variety of foods and limiting intake of fat. Dietary requirements, such as the recommended daily allowances, the RDA, are best to follow. Food pyramids can offer suggestions for following a healthy diet by organizing foods into suggested portions. The USDA's MyPlate now replaces past food pyramids. Nutritional information as well as ingredients are listed on most grocery items for retail sale. Table 18.11 illustrates the types of vegetarian diets. There are vegans, ovo-vegetarians, lacto-vegetarians, lacto-ovo-vegetarians, pesco-vegetarians, and semi-vegetarians. A vegan is the strictest. It has no animal foods whatsoever and oftentimes no animal products in their lifestyle. Ovo-vegetarian has eggs allowed but no dairy or meat. Lacto-vegetarian is dairy allowed, no eggs or meat. Lacto-ovo-vegetarian is dairy and eggs allowed, but no meat. Pesco-vegetarian is dairy, eggs, and fish allowed, no other meat. Semi-vegetarian is dairy, eggs, chicken, and fish allowed, no other meat. Figure 18.21 shows the My Plate developed by the USDA. And these are suggestions for the types of fruits, vegetables, grains, and proteins, along with dairy. And so I always think of it as like 80-20. You need like 80% plant-derived foods and like 20% animal-derived foods. That's just my take on it. Nutrition and the athlete. Athletes and sedentary people have different nutritional requirements. Frequent, strenuous activity can be supported by a diet consisting of 60% carbohydrate, 18% protein, and 22% fat. Athletes should eat most carbohydrates from vegetables and grains and eat frequently. Athletes should eat 25% more protein than sedentary people. Athletes should drink a lot of water to counteract the effects of sweating. And if following a balanced diet, athletes should not need vitamin or mineral supplements. Creatine supplements do not seem to improve athletic performance, except maybe during peak exertion, when natural creatine phosphate may become depleted. Creatine supplements seem to make muscle cells enlarge, but this is due to osmosis of water into the muscles, not an increase in the size of muscle cells. Malnutrition is poor nutrition that results from a lack of essential nutrients or the inability to use them. Remember our discussion about the lack of intrinsic factor, not being able to absorb the B vitamins. Also, in the previous chapter, we talked about the lining of the gut, and if it is diseased, it will not be able to absorb the proper nutrients, leading to malnutrition. There's two types of malnutrition, and this may surprise you. Undernutrition you are aware of, but overnutrition you may not be aware of. So undernutrition is malnutrition resulting from deficiency of essential nutrients. Malnutrition from excessive nutrient intake is overnutrition. And so again, that's what can lead to obesity. And a lot of times when folks suffer from obesity, the nutrients that are being taken in are largely fats and sugars. So the causes of malnutrition is lack of food availability, poor quality of food, overeating, and taking too many supplements. And then you've also heard of like food deserts where healthy food is not available. And this is a crisis in this country where the only food people have access to are fast food, quick stops, and then the junk in the center of the grocery stores. And a lot of times healthy foods are either not available in the area or they are cost prohibited from the people who need them. The classifications of malnutrition include primary malnutrition and secondary malnutrition. Primary malnutrition is from malnutrition from diet alone. Secondary malnutrition is an adequate diet, but the individual characteristics make the diet insufficient, such as a person with a deficiency of bile salts developing a deficiency of fat-soluble vitamins. Or if they have the deficiency of intrinsic value, they can't absorb B vitamins. Starvation. A healthy human can survive 50 to 70 days without food. Not so for water, right? We'll die real quick without water. During starvation, the body will begin to digest itself, slow and painful death. Symptoms include low blood pressure, slow pulse, chills, dry skin, hair loss, and poor immunity. Common nutritional and starvation disorders are marasmus, which is due to lack of calories and protein, kwashiorkor, which is protein starvation, anorexia nervosa, an eating disorder, which is self-starvation, and bulimia, an eating disorder with binge and purge cycles. When we talked about the edema from protein deficiency, the kwashiorkor is going to be telltale with the swollen belly and the edema. Lastly, we'll talk about lifespan changes. So dietary requirements remain about the same throughout life. The basal metabolic rate rises in early childhood, peaks in adolescence, and declines in adulthood. A change in nutrition often reflects the effects of medical conditions and social and economic circumstances, such as depression, tooth decay, periodontal disease, diabetes mellitus. A deficiency of vitamin A may take a long time to show up. Calcium deficiency may not show symptoms as bones lose mineral content, and that can lead to osteoporosis. Vitamin D deficiency may develop in the absence of sun exposure. You can see that energy requirements decline with age, but not terribly. So for female, 23 to 50, 2,000 calories, 51 to 74, 1,800 calories, 75 plus 1,600 calories. Male, 27 calories for 23 to 50-year-old range, 2,400 calories for 51 to 74-year-old range, and 2,050 calories for a 75 plus. And it's actually pretty difficult to stay within this caloric range. I have to watch my nutritional intake every day. I enter it into MyFitnessPal because I very readily and easily exceed that 2,000 calorie a day range if I am not careful. I actually exceeded it today by, 41 calories, and I have my goal as 1,880 calories. But I gave myself a little bit extra today because I swam, and then I also donated blood, which expends calories as well as you have to replenish that blood supply over the next few weeks. But tomorrow I'll try to do better and stick to my 1,880 calories. And that is all for this chapter. Thank you.